सो हे गाइस, वेलकम बैक टू हसन एसएससी वाला। और आज के इस वीडियो में हम लोग डे 23 का मेंसुरेशन 2 कवर करने वाले हैं। मेंसुरेशन 2 इज़ बेस्ड ऑन 3D फिगर्स। द सोर्स ऑफ इंफॉर्मेशन इज टेकन फ्रॉम पेज 252 ऑफ AC SSC Advanced ebook Adda 24/7. The learning outcomes. For previous chapter, you have learned about the measurement of length, hypotenuse, height, diagonal, perimeter, area of triangle, quadrilateral, polygon, circle, and these are all based on 2D figures. But in this chapter you are going to measure the area. Area is in terms of lateral surface area and total surface area, the volume of a cube, cuboid, right prism, and right prism with lateral surface as curved is cylinder, a sphere whose all side is curved, and pyramid with a curved lateral surface is a cone. Pyramid with one top face as pointing uh, is a cone, and right prism with its all the side being lateral surface smooth is cylinder, and pyramid with lateral surface smooth is cone. A frustum is a cut cone. Tetrahedron with four equilateral triangle, or with four triangles, and these all are based on 3D figures. Also, sphere and cylinder has a hollow shell version, and for those also the area and volume has to be seen. Captured volume concept. The concept of the captured volume. The volume captured within a cylinder. So within a cylinder, if the cylinder is of height radius r, then it captures a volume of sphere, a hemisphere with a volume of 2 by 3 the volume of the cylinder. And if the cylinder height is twice the radius, then it captures a complete sphere, which is 1/3 the volume of cylinder, which is 1/3 the volume of cylinder. Sorry, which is also 2/3 the volume of cylinder, means the sphere is covering the 2/3 volume of the cylinder, and hemisphere is also covering the 2/3 part of the cylinder. But a cone covers 1/3 volume of cylinder. A cone, any height, any cylinder, every cylinder with any height has a cone inbuilt in it, with a volume of 1/3 of the volume of cylinder. So the first figure of today is a cube with all the sides equal. So its diagonal is side is a, face diagonal is √2a, and the cube diagonal is √3a. And telling about the surface area is 6a square. About the volume, it's a cube. Then now it's about cuboid. It has length, breadth, and height. Then its surface area is, lateral surface area is 2 into l plus b into h, whereas the total surface area is 2 into lb plus bh plus lh. Total surface area. Talking about the volume, it is length into breadth into height, and the diagonal is root under l² plus b² plus h². Now coming to right prism. After cuboid, then we are coming to the right prism. What is a right prism? In a right prism, the face of bottom and the top face, these both consist of a regular polygon. The top face and bottom face has regular polygons, whereas the lateral sides has rectangles, and it is n number of rectangles, because n number of rectangles have n sides of a regular polygon, which is the top and the bottom section of the right prism. And right prism has n sides of A, NA, and n heights NH. NH curved lateral lines. So coming to the lateral surface area is the perimeter of the perimeter of the regular polygon into the height of the right prism, and the perimeter of the regular polygon is equals to number of sides into the area of each equilateral triangle consist in it. Also, the area of uh, regular polygon is equals to the height, the distance between the center of the polygon to the perpendicular to any sides, which is multiplied by any sides, which is multiplied by perimeter of the sides divided by 2. So it is like half into base into height, and the base is the complete perimeter, like we can see as it is here. Perimeter into height is the lateral surface area. Total surface area is lateral surface area plus 2 into n into the complete triangles. And now talking about the volume, it is the area of base. Area of base is calculated by two formulas, like n into area of each triangle, and it is like the perimeter of the regular polygon, perimeter of the regular polygon into the distance between the center and the perpendicular, that is the perpendicular, that is the radius, orthoradius, and divided by 2. This is how base area is calculated. So base area into height is volume. Now coming to a right circular cylinder. What is a right circular cylinder? It is nothing but a cylinder with two top and bottom face as a circle. So it has R and L as the dimension. R is the radius, L is the lateral surface, L line, length of any lateral surface. So what is the lateral surface area? It is 2 pi R into L, and total surface area is 2 pi R plus L. Total surface area is 2 pi. So the lateral surface area of a right circular cylinder is 2 pi R into L, and the total surface area is 2 pi R into L plus R, and the volume is pi R square into L. Talking about a pyramid. What is a pyramid? A pyramid is base with a regular polygon, and it is converging to a point above the base. The bottom face is a regular polygon. Lateral side has n number of isosceles triangle. Lateral sides have triangle, n number of isosceles triangles. So the difference is about the triangle, lateral sides triangle, and the rest all are same. So the lateral surface area will be equal to n into number of triangles around the lateral surface, whose area is root 3 by 4 a square, and n will be equals to the number of side of the regular polygon. Volume will be equals to the 1/3 of the area of base into the complete height, the height of the pyramid, like 1/3 area of base into height of the. So in a pyramid, the lateral sides are isosceles triangle, and it has n isosceles triangles lateral sides, whereas the base has n number of equilateral triangles n number of equilateral triangles, and the lateral sides have n number of isosceles triangles. That's okay. Now the lateral surface area will be equals to n into the area of each isosceles triangle. Area of isosceles triangle is a by 4 into root under 4l² minus a square, where a is the base and l is the lateral side. L is the lateral and equal side, and total surface area will be equals to area of the isosceles triangle n isosceles triangle plus the area of n equilateral triangle in the base. And talking about the volume, it is 1/3 the area of the base into the height of the pyramid. 1/3 the area of the base into height of the pyramid. Here height, this is the actual height of the pyramid. This is not the lateral surface area. This is the height of the pyramid. So it should be calculated, and it can be calculated. And how it can be calculated? The lateral surface area is given, the A is the side given, and height can be calculated by l² plus a² under root. Now figure 6 is the figure of cone, and in a cone there is r radius, l is the lateral side, and h is the height. So the lateral surface area will be pi r l, into l, and the will be pi r l means it is the half the area of a cylinder, means pi r l, and total surface area is equals to pi r into r plus l. It is pi r into r plus l, whereas in right circular cylinder it is 2 pi r into r plus l. So it is to be noted as pi r into l plus r. So here comes the total surface area, and about the volume, it is 1/3 the area of the cylinder, which is pi r square h. H is the height. It is to be noted. Now the seventh figure is the figure of sphere. It has only radius. All of the sides are curved. It has no perfect length side. So total surface area is equals to 4 times of pi r square, and the for a hemisphere it is 3 times of pi r square, and for lateral surface area of a hemisphere it is 2 pi r square, and for volume it is 4 by 3 pi r cube. In a spherical cell it has r radius, small r radius, and capital R big radius. So the lateral surface area, the total surface area, in this total surface area will be pi r, the total surface area in complete sphere. What is that? 4 pi r square. So here it will be 4 pi the sum of the square of each radius, and the volume will be 4 by 3 pi into the difference of the the cube of the radius. Here difference is taken because the inner volume is calculated, and total surface area is as the sum. It is sum. So volume will be less. And coming to hemisphere, the total surface area will be 3 pi r square, lateral surface area 2 pi r square, and the volume will be, it is 2 by 3 pi r cube. And frustum is very important. What is frustum? It is a cone with top face cut. A cone with top face cut. So the word frustum can be remembered like whenever a cone is cut, whenever cone ice cream is cut from the bottom and taken from the bottom, there is a anxiety that whole of the ice cream within the cone will fall down. So it is frustrated. It is like giving frustration that whole ice cream will be fall down. So whenever a cone is cut from the bottom, then it is frustum. So it has a r radius at the top, and small r radius and capital R radius at the bottom, and L is the lateral surface area, H is the height. So a lateral surface area will be, it is like same as a cone. It is pi r l. It is pi r. It is pi r l. But the thing is there are two radius. So r will be sum. It is pi into small r plus capital R into L. And the total surface area. What was total surface area for a cone? It was pi r into L plus R. So here it will be pi, total surface area will be pi r l. So the total surface area is slightly different. So in a frustum it is very important to note that all of that whenever we have to calculate the total surface area, we have to calculate it individually. Like for the upper circle it is pi small r square, for the below circle it is pi capital R square, and for lateral surface area it is pi capital R L plus pi small r L. So here the area will be more. Area is much more than the area of a cone, because if we are making the area of cone within that pointed thing, then it will be less, because it has a broader top. So the area is more. And how much quantity? By how much quantity? By the quantity of pi r l, pi small r l, by the quantity of pi small r l. It is more, pi small r l. So I am holding this one, pi small r l is added. And talking about the volume, it is one third the volume of cone. One third pi. What was like for a cone? It was one third pi r square into h. One third the pi r square h. So here also one third pi r square. For r square it will be r square capital R square plus small r square, plus it will be capital R into small r. So it is important for capital R into small r. This is extra added. And for L square, there is two more important formula coming in this first term, is that this L square is equals to this H square plus this base. This base is the difference of the radius, this complete R minus this small r. So this one radius, R minus R square plus H square will give L square. And the frustum relation is that like this is the base, and this much is the height, and this much is the height of the complete cone. So this base radius divided by the base of the cone, radius of the cut cone divided by radius of the cone, is equals to height of the cut cone divided by height of the cone. So it is like cone is common in frustum. So the last figure is the figure of tetrahedron. What is a tetrahedron? It is a combination of four triangles, and whenever the four triangles are congruent and equal, then it is called a regular tetrahedron. So in general computation, it is regular tetrahedron is only seen. So it is a triangular pyramid also, we can say. So the lateral surface area has three triangles, so it will be 3 into the area of equilateral triangle. 3 area of each equilateral triangle. 3 area of equilateral triangle is the lateral surface area. Total surface area is the 4 area of of equilateral triangle. And about the volume, it is like this is important for the volume. Volume of tetrahedron, it is important because the volume of tetrahedron is like root 2 a cube divided by 12. So it is very important because in a tetrahedron the side A is given, and then this like this is the base of the triangle. So the side A is given, this side A is given, and now this side A is given, and now this one, this perpendicular which is the in center radius, radius, its value is a by 2 root 3, and the value of equilateral triangle height. So this complete triangle of base is an equilateral triangle, and its height value is root 3 a by 2. So what we are trying to do here is we are trying to apply a Pythagoras theorem. So the base triangle, in a base triangle there is a first of all there is a in center radius, and then the slant height. In a slant height of triangle there is a height, and the height is root 3 by 2a, and this in center radius is a by 2 root 3. So this height can be calculated by the reciprocal, like it is root 2 by root 3a, like here root 2 by root 3a. Height of the tetrahedron is, so here it is wrongly mentioned. Height of the tetrahedron will be root 2 divided by root 3a. So root 2a by 12, it is the volume. Root 2a by 12, root 2 a cube by 12, it is the volume of the tetrahedron, but root 2 by root 3 times of a is the volume of is the height of the tetrahedron. So whenever we are multiplying the height of the 1 by third into height of the tetrahedron into area of the base, we will give the volume of the tetrahedron. So this is the height of the tetrahedron, sorry. So this is the height of the tetrahedron. So in denominator 3 will go, because 1 by 3 height of the tetrahedron into area of base. Area of base is root 3 by 4a square. 4 into 3 is 12. And so root 3 will be cancelled. 4 into 3 is 12. Root 3 by 4 a square, and a square will be multiplied, it will give a cube, like root 2 by 12 a cube will be the volume. So here's the end of today's mensuration to 3D figure, and meet you in the next video.